Alright, here comes part 2 of the video. We've already done problems 1 through 5 where we added and subtracted and evaluated and even multiplied some functions. In part 2 we will continue multiplying functions and we will practice our binomial expansion using Pascal's triangle, and we'll go over some terminology about functions. Once again, please put your pencils down. Make sure you have attempted these problems before you watch the video, and even if you are stuck, go ahead and watch the video without a pencil in your hand, learn how to do it, and then go back and get the practice by doing it yourself. Number 6. Anytime we multiply a binomial times a trinomial, or really any polynomial times a polynomial, it comes down to the distributive property. Sometimes you just have to do it more than once. So first I'm taking this x and I am distributing the x. X times x squared is x to the third power. X times x is x squared. X times -6 is -6x. Alright, now I will distribute the -2 like so. Alright, -2 times x squared is -2x squared. Notice how I line up my like terms. I recommend you do the same. -2 times x is -2x. And -2 times -6 is +12. Then you just combine those like terms that I mentioned. X to the third power just comes down. This is like 1x squared. So 1 and -2 make -1. We don't put the 1 though, so I'll just put -x squared. -6 and -2 make -8. So -8x. And then +12. So this will be our answer for number 6. Okay. Number 7, we can really do it the same exact way. I will start with the 5x and distribute. 5x times 3x is 15x squared. 5x times 7y. Well, 5 times 7 is 35, so I've got 35xy. Now I will distribute the y. Y times 3x is 3xy. Alright, just put them in alphabetical order. Y times 7y is 7y squared. Notice how I line up my like terms. You should do that. It's cool. Now, combining like terms, I have 15x squared plus 38xy plus 7y squared. So there's your answer to number 7. Alright, switching gears a little bit, we're supposed to do this binomial expansion, and we're going to use Pascal's triangle to find it, because it'll be a lot quicker than having to do x minus 3 times x minus 3 times x minus 3 times x minus 3. This would take a long time. So here's what we're going to do instead. Like we've learned before, you can generate Pascal's triangle anytime you want. It always starts off the same way, with a small triangle of ones. After that, you pick any two numbers, add them up, and put the sum in the middle. So 1 plus 1 is 2, and I put that in the middle. Now the ends are always ones. So I will do it again. 1 plus 2 is 3, just put it in the middle. 2 plus 1, there's another 3. Alright, the ends are always ones. Alright, do the pairs. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. Put those ones on end. Okay, and you can go as far as you want. I'm going to go one more level down. 1 plus 4 is 5, and then these two give us 10, and there's another 10 from the 6 and 4, and another 5, and the ends are always 1s. Okay, so it turns out that each one of these rows will give us the coefficients of a binomial raised to a power. So just understand that this very first row this is the coefficient you would get if you did a binomial to the 0 power. Alright, anything to the 0 power is 1, so that makes sense. So just make sure you start with the 0 power, and then everything else will go in order. So this next row, this is what I would get if I do x plus y to the first power, binomial to the second power, third power, fourth power, fifth power. Alright, but these are the coefficients in every case. And I could keep going 6th power, 7th power if I wanted to or needed to. Okay, now back to business. So looking at this, we have the 4th power. So what I want you to do is just grab the coefficients. So 4th power, the coefficients are 1, 4, 6, 4, 1. Okay, so start with those coefficients. Okay, space them out as far as you can. So 1, 4, 6, 4, 1. Okay, they always start off positive. Alright, now what I want you to do is start with the term on the left. I've got x. I'm going to start with that on the left next to this 1. And then I will use the degree. So I start with x to the 4th power, and then I begin to decrease. X to the 3rd power, x squared, just x, and the last term doesn't get any x's. Alright, but then I switch it up and I do the second term. This is a -3. You must include the negative sign, and I recommend using parentheses. Since this is on the right, I'm going to start off on the right. So there's my -3. Again, the degree starts off at 4. And then as I go to the left, I decrease. So I have -3 to the 3rd power, -3 squared, just -3, and then the last term doesn't get any. Alright, so all I really have to do is simplify this, and then I'll be done. What I recommend though is if I would do all the powers if I were you before I do anything else. So everything you see here in green, go ahead and evaluate it. So that's what I'm going to do right now. Okay, so -3 to the 4th power is going to be positive 81. Okay, I know that in my head, but if you need it, then put it in the calculator. Alright, -3 to the 4th power is positive 81. Please remember that if I do an even power, it's going to be positive. If I do a negative number to an odd power, it's going to stay negative. So this should be positive, negative, positive, negative. It alternates. Be careful how you put it in your calculator. If I had typed this in as -3 to the 4th power without parentheses, it would have given me a -81, and that is wrong. So always use parentheses. Anyway, so that's 81. In a similar way, -3 to the 3rd power is -27. And of course, -3 squared is positive 9. And then, you know, I still have my -3 sitting there. Okay, so instead of using the green, I am now using the purple. Alright, so you can sort of ignore the green part now and focus on the purple. So as I do this problem, this is what I'm going to have. From this term, I just have x to the 4th power. That 1 is not is no longer needed. Now here I have 4 times negative 3. You know what I mean? The x to the 3rd power. You know, maybe I should keep the colors a little bit longer. All of these variables in blue, they're all coming straight down. So I have x to the 4th power, x to the 3rd power, x squared, and x. Okay? But I'm multiplying the coefficient times the purple number here, and that will be my new coefficient. Okay, so now 4 times negative 3 is negative 12. So this term will have a coefficient of negative 12. 6 times 9 is 54, positive 54. 4 times negative 27. I'm pretty sure that's negative 108. But let me check it out. Okay, 4 times negative 27. Yeah, negative 108. And then, of course, 1 times 81 is just 81. Alright, so that is the final answer using Pascal's triangle. Much quicker than doing it x minus 3 times x minus 3 times x minus 3 times x minus 3. There is no number 9. I don't know what happened to it. Alright, but number 10, using Pascal's triangle still. It's the 3rd power, so let's take a look. 3rd power. So that's 1, 3, 3, 1 are the coefficients. Okay, so start with that. So 1, 3, 3, 1. And they always start off positive. Okay, so let's start with the 2x. Please put the 2x in parentheses. It's on the left, so we start on the left. 2x to the 3rd power. And then we decrease, so 2x squared, and then just plain 2x. The last one doesn't get any. Alright, then we do the 4. The 4 is on the right, so we start with 4 on the right. Same degree, 4 to the 3rd power. As I go to the left, we decrease. So 4 squared, and then just plain 4. The last term doesn't get any. So we just need to simplify this. Just like I did last time, I recommend doing all of the exponents first. Okay, but this time I have exponents on the green part and the blue part. So rather than just writing numbers floating around, I'm just going to redo the problem. Okay, the coefficients are not changing right now, so I'm still going to have my 1, 3, 3, 1. Alright, I'm just bringing those down. And I'm going to keep the colors so you can keep track easily. So here's the first common mistake that students will make. I have 2x to the 3rd power. Please make sure you do 2 to the 3rd power and x to the 3rd power. A lot of kids just don't put parentheses, and they'll just put 2x to the 3rd power, and that's wrong. 2 to the 3rd power is 8. Okay, so you should have times 8x to the 3rd power once you cube it. Similarly, on this term, I have to square the 2 and the x. So 2 squared is 4. So I have 4x squared. Okay, I'm just bringing down all the blue stuff right now. And then I've got my 2x. Now I'm going to go back and do the green stuff. Alright, so I've got my 4. Okay, that doesn't have a power on it. 4 squared is 16. 4 to the 3rd power is 64. Okay, so again, after you set it up, do all of the powers. make sure if you have a monomial like this, you do the 2 and the x to the power. Alright, now I can just multiply all the regular numbers together. Okay, so as I look through this thing, there's my x to the third power, and here's my x squared, and here's my x. Okay, so 1 times 8 is 8, so I'll have that. Now I have 3 times 4 times 4. Okay, 3 times 4 is 12. 12 times 4 is 48. So I'm going to have 48 x squared. 3 times 2 is 6 times 16. Alright, my brain's getting tired, so I'm going to put this in the calculator. It was 3 times 2 times 16. So you could just do it all. 3 times 2 times 16. Okay, that's 96. Okay, so that's 96x. And then of course 1 times 64 is just 64. So that is the answer for number 10. Okay, so switching gears, moving into vocabulary and such. Standard form. When you rewrite a polynomial in standard form, the highest degree term should be first. So when I talk degree, I'm talking about exponents. So see that x to the fourth power? That is the highest degree term, so that must go first. Alright, so in standard form, I will start with negative 7x to the fourth power. Notice how the negative sign goes with it. Next is going to be the x term. Okay, that positive 4x is next, so I will put positive 4x. And then that negative 8 is the last. Alright, decreasing exponential order. 4, 1, none. Now the degree. The degree is going to be that highest power. So in this case, the degree is 4. The leading coefficient is the coefficient of the highest degree term. If you put it in standard form, it'll be the one in the front. So the leading coefficient is negative 7. The constant term is the term that doesn't have any variable. So that's negative 8. Okay, similarly, number 12. The highest degree term is this positive 3x squared. So that goes first. So 3x squared. Next comes the 15x. And then last is the minus 7. So the degree is 2 because of the highest power. Leading coefficient is 3. The constant is negative 7. Okay, so for number 13, we're supposed to classify polynomials by degree and term. Alright, that's going to be things like phrases like cubic, binomial. Alright, cubic would refer to the degree, alright, if we were dealing with x to the third power. And binomial has to do with the number of terms, alright? That would be 2 terms. So a cubic binomial, for example, might be if I had 5x to the third power minus 7x. Alright, it would be cubic because the degree is 3, and binomial because it has 2 terms. So that's what we're doing. Okay, so this, just the number 7, because it doesn't have any variables at all, it is constant. And because it only has 1 term, it is a monomial. Alright, that is a constant monomial. For B, because the degree here is 3, it is cubic. And because it has 2 terms, it is a binomial. That's just like the example I gave. This is a cubic binomial. Okay, a lot of cubics today. Because the degree here is 3, this is also cubic. Because it has 3 terms, it is a trinomial. Okay, and I guess that's it. I want to hit a few more of those terms. So even though that's the end, here's a couple more examples. Please understand, let's see, if it was something that had x squared, like say if I had x squared plus 5x. Degree 2 is called quadratic. So this would be a quadratic binomial. And degree 4, okay, if I had 5x to the 4th power minus 2x to the 3rd power plus 1. When you have degree 4, that's called quartic. So this would be a quartic trinomial. Anything over 3, and we just say polynomial. But I really want to emphasize that when it's degree 2, we say quadratic. Alright? A lot of times kids will see the quad and think that goes with the 4, because quad normally means 4. But no, quadratic is squared. For 4, you have to go quartic, like a quart of milk. Alright, just memorize that. Alright guys, I'm pretty sure we've finished the entire assignment. Let me just take a step back and make sure I'm not missing anything. Nope, that was it. So I really hope this video has been helpful to you, and good luck, and I will see you on the next video.